that we have to go through. The first thing is to find all the zeros. If it's in factored form, that's really easy to do. We've done that. We did it on some examples yesterday. We had done it before. If it's not in factored form, you might have to do your P's and Q's and possible zeros. So go through that whole bit that we did in the last section to get it in factored form so we can find those zeros. When you're looking at a graph, where do those zeros go? Those are your x-intercepts. So you will plot those on the x-axis. Okay, the behavior at the zeros. That's asking you, is it going to go through or bounce at each? Remember, what makes it bounce? Even multiplicity, squared, fourth, sixth, so forth. If the multiplicity is odd, it will just go through. In behavior, that's determined by that leading term. We know odds look like the chair, evens look like a parabola. Y-intercept, how do you find a y-intercept? Yeah. You have to plug in 0 for your x, and then that will be where you hit the y-axis. And then we can draw the graph. We plot all of our points, the x and y-intercepts, we look at the end behavior, and we draw the final graph. So the first one, I'm going to do one that's already factored for us. So we are going to draw this graph. All right, so first thing I need to do is find out my zeros. To do that, you just set, if it's already factored, each parenthesis equal to 0. So what makes 2x minus 1 equal 0? It doesn't have a power, so it's just multiplicity of 1. X plus 1 would be an x plus 3. For each of these, we need to decide if the graph will bounce or go through. They all have a multiplicity of 1. 1 is odd, so what will happen? You'll go through. Okay. End behavior. Okay, that's based off the degree. If I multiply this out, if we just took our powers of x and multiply them together, you get a 2x times an x times an x, or a 2x cubed. You can also get the degree by looking at the number of zeros. We have 3 zeros, so it's a cube. So I don't have to multiply the whole thing, I just need that leading term. If it's a cube, it will be what in behavior? Down, up. Remember, odd powers will always be going different directions. If your coefficient was negative, that flips them, so then it would be up, down. All right, y-intercept. To get that, you plug in 0 for all of your x's. So 2 times 0 minus 1 is negative 1. 0 plus 1 is 1. 0 plus 3 is 3. Negative 1 times 1 times 3 is negative 3. This is actually all I need to get a sketch of my graph. So I hit my x-axis at 1/2, negative 1, negative 3. I hit my y-axis at negative 3. In behavior is down, up. So we are going to start down here, and we said at each of those zeros we will go through. So we have to go through. We have to turn back around and hit the next 0. Come down. We have to hit our y-intercept. We have to hit the following 0, and it said go through, so it ends up. Now, is this graph perfect? No. What is perfect about it? What's accurate here? The points. The x and y intercepts are great. If you compared it to your calculator, so originally we had 2x minus 1 times x plus 1 times x plus 3. So it's not too bad. It looks like like maybe my graph went a little higher there than I drew it, but without getting some more exact points, I have no way of knowing that. What I am looking for when I grade these, I'll check your intercepts, I will check your in behavior, and I'm going to look, did you correctly bounce or go through at each of those zeros? And then of course you always have that calculator to double check yourself in the end. All right, any questions on that one? Okay, well, let's keep going. Alright, so I want to sketch this one. It is not already factored for me. So what am I going to do? Okay, we need to do our P's and Q's so we can get a starting point, and then we could do our synthetic. So the P comes from the constant, so everything that goes into 16 evenly. So that would be 1, 2, all these get a plus or minus. 4, plus or minus 8, plus or minus 16. What are my Q values? So the possible zeros, that's P over Q, so 1 over 1, 2 over 1, 4 over 1, you're just getting these P values again. So those are all the things that might work. How do we find which one does work? Now we're going to kind of cheat and use our graph to help us get a starting point. So you're looking for one of those x-intercepts. Now, guys, I'm fully aware you're graphing it to figure out how to graph it. Like, I know how silly that sounds, but I still need you to learn this process, okay? So we're finding one that makes it equal 0, and what would that be? -2? Okay. So then we can do our synthetic. So 1 comes down, multiply, we get -2, add, get -4, multiply 8.
So we had to put in 0.
Yes, thank you. Did not have my x squared. Okay, so then multiply those to get 8, adds to 8, multiplies to -16, that's a -8, 16 is 0. So at this point I have x cubed minus 4x squared plus 8x minus 8. Is that good enough? So I need another 0. What else works?
2.
So you can look back at the original graph and find another place where it hits the x-axis where you can graph the answer to that, and we divide again. So this gives me x squared minus 2x plus 4. Is there anything that multiplies to 4 and adds to -2? No, so how do I solve that? Quadratic. This is not a pretty one, is it? So opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So we get 4 minus 16. Okay, what's going to happen there? Right, it's going to be imaginary. Now, if we were just trying to find all the zeros, then we need to go ahead and finish this. If my goal is to draw the graph, can I graph those imaginary zeros? No. So do I really have a need to go ahead and find those two numbers? Not really. You can, there's nothing wrong with that, but it's not going to benefit me because my whole purpose is to find the zeros that we can graph. we're looking for the x-intercepts here. So what values did work?
2 and -2.
Okay. Both of those have a multiplicity of 1, so what will happen to my graph? Go through or bounce? Through both of them. Okay, next thing. End behavior. The original graph, we had an x to the 4th. So what should that look like? Up, up. Gonna look like a parabola. My y-intercept. So if I plug in a 0 for all of my x's, what do we get out? Okay, so let's plot all this stuff. We hit the x-axis at -2 and +2. Both ends should be pointing up. Hit the y-axis at -16. I'm going to count by 4s. Just make sure if you're not counting by 1 that you label that. Okay, so then my graph should start up here. It should come down and hit my x-intercept. We said it went through, so then it's got to come down and hit my y-intercept. Have to go back up to hit this other x, and we said it went through, so something like this. Now, is my graph perfect? Absolutely not, but my ends are going the right direction. My intercepts are correct. We have the general shape of this graph. Questions there? This one. It's not factored, which tells me P's and Q's. However, Q has to be the constant. Do I even have a constant here? No. Don't forget your other rules of factoring. P's and Q's are when we don't have another option. What could I do to factor this? Take out an x. I'm going to go ahead and pull out a negative x just because I prefer for my first term to be positive. So, if I pull out a negative x, that leaves me with a positive 2x squared, positive x, and a minus 1. What can I do with this? So those multiply to a -2, and I need them to add to a positive 1. So if we factor, we get 2x minus 1, x plus 1. So my polynomial is -x times 2x minus 1 times x plus 1. Alright, side note. Come back and look at this first one that we did P's and Q's on. Is there another way? Is there a way I could have factored that one nicely? There's no great common factor. When there were 4 terms, what did we usually try? Grouping. What could you have taken out of the first group? That would leave us with an x minus 2. What can you take out of the second group? then they both have the x minus 2, so you could pull that out, and you're left with the x cubed plus 8. And then could you set each of those equal to 0 and solve? Yes. So some of these, there's multiple ways. If you recognize that, hey, I can do this by grouping, that's significantly faster. But if you didn't, P's and Q's still work. Okay? P's and Q's, that's like our last resort if our other factoring techniques don't work. Alright, so this one, my zeros. What makes negative x equal 0? What about 2x minus 1? And x plus 1? Okay, all of these have a multiplicity of 1, so we will go okay. The end behavior. That's easiest if you just looked before we started factoring. X cubed is a chair, but the negative would flip it, so we have up there. Y-intercept, if you plug in 0 for all of your x's, you can do it in the factored form or the original. Either way, we get 0. I hit my x-axis at 0, 1/2, and -1. Starts up here, ends down here. The only place we hit the y-axis is also 0. So if we draw that, we're coming down, we said we went through. You have to come back to hit your next 0. We went through. So it looks something like this. The next one, I would like for you guys to try it on your own. At least list out all the information for me. If you don't know what to do with the graph, at least get the information. What are my zeros? Okay, so this one, even multiplicity, so it will bounce. This one, odd multiplicity, so it will. Okay. Next step in behavior. So we have to think about if we multiplied this out, what would we get? The first parenthesis would give us an x squared, then we get an x cubed. So overall this is x to the 5th. So what would my end behavior be? Down, up. Y-intercept. If you plug in 0 for all of your x's, you get -1 squared times 2 cubed. So that's 1 times 8, which is 8. Alright, so I hit my x-axis at -2 and 1, y-axis at 8. It should start down here and end up here. But what happens at my -2? Do we bounce or go through? Go through. Come back and hit the 8. And then at the 1, we bounce. Couple things about this. It is a polynomial. That means the graph is a curve. If you have corners, like an absolute value in there, that's wrong. It's a curve, like a parabola or a cube. So no sharp corners, no breaks in your graph. Also, it has to be a function. It has to pass the vertical line test. So if you're drawing a graph and you draw something like this, is that okay? No. So make sure, adjust if necessary. It has to be a function at the end. It needs to be nice and curved. Okay? One last problem. See how far you can get on your own. a 0, you look at the multiplicity. 5 is odd, so it will go 3 is multiplicity of 1, so it will go. They have 4 multiplicity 4. 4 is even, so it will. Okay. In behavior, if you multiply this out, you have an x to the 5th times x to the 4th. So overall, that's x to the 10th. So what should our in behavior be? Y-intercept. If you plug in 0 for all of your x's, you get 0. We hit our x-axis at 0, 3, -4. Y-axis at 0. Both ends should be pointing up. Hit my x-axis, and this is the one that says bounce. So you gotta come back up. At 0 we go through, and at 3 we go through. If you get to the end and your in behavior doesn't match what you said it would be, you've made a mistake somewhere. Either you didn't bounce when you should have, or you crossed the x-axis somewhere other than where you have a 0. Okay, those zeros are the only places you can hit the x-axis. Are there any questions on that?
Okay, how does the y-intercept?
You plug in 0, you get 0 to the 5th, which is 0, times -3, which is 0, times your 4 to the 4th, so still 0. On one of these questions, I failed to answer the second part of it, and I just remembered. This one, I asked a bunch of other questions, didn't I? And then I didn't even answer any of them. I apologize for that. So let's run back to that example real quick. I asked you what are the x-intercepts. What's another word for x-intercepts? Zeros. What did we get for the zeros? Okay. This says where is p of x less than 0? So look at your graph. Where is that graph less than 0? Between -2 and 2. And then I said where is p of x greater than 0? 0 is just your x-axis. So I'm just asking where is it above the x-axis? So that's this part and this part. You have to give me the x values. So that's coming from -infinity, stopping at -2. The next piece starts at 2 and goes to infinity. Alright, so the last couple problems, they give you the graphs in the factored form and they're asking you a couple things like that. Any questions for me? Okay, so we've got quite a bit of time. Here is your assignment.